Hello! In this video, we are going to prove the following corollary. Let A and B be integers that are not both 0. Then A and B are relatively prime, if and only if there are integers s and t such that as plus bt is equal to 1. Okay, now before we get into the proof, let's get some context. First of all, we're going to say that given any two integers a and b that are not both 0, we say that a and b are relatively prime if their greatest common divisor is 1. Second, we're going to use a fact that we already know in order to prove this. And it's that given any two integers a and b that are not both 0, the greatest common divisor of a and b is the smallest positive integer of the form as plus bt. Where s and t are integers. Okay, now let's get into proving this corollary. To start out the proof, let's give ourselves two integers a and b which are not both 0. Well then, by the fact that we already know, we have that there are integers x and y where the greatest common divisor of a and b is equal to ax plus by. And the greatest common divisor of a and b is the smallest positive integer of this form. Now let's get into proving what we want to prove. Right? We want to prove that this is true if and only if this is true. And we're trying to prove a statement containing if and only if. So what we're going to do is we're going to prove if this is true, then this is true. And then we're going to prove if this is true, then this is true. Let's start by proving the forward. That is, let's prove if this is true, then this is true. To do so, suppose a and b are relatively prime. What does it mean for a and b to be relatively prime? It means that their greatest common divisor is 1. Well, we know that the greatest common divisor of a and b is equal to ax plus by, so we can substitute this for ax plus by. So what we see here is that there are integers s and t such that as plus bt is equal to 1. Namely, if we choose s to be x and t to be y, well then as plus bt is equal to 1. So we have proven that this is true. So if this is true, then this is true. Now we're going to prove the converse. That is, we're going to prove if this is true, then this is true. To do that, suppose that this is true. Well then, 1 is a positive integer of this form. But the greatest common divisor of a and b is the smallest positive integer of this form, so the greatest common divisor of a and b must be less than or equal to 1. However, since GCD of a and b is a positive integer, it must be greater than or equal to 1. So this tells us that the greatest common divisor of a and b must be equal to 1. But this is exactly what it means for a and b to be relatively prime. So we have proven if this is true, then this is true. So we have proven both directions of the if and only if, which means we've proven the entire statement. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.